In my last video I used alligator clips to clip to these wires and then the battery from this voltage booster module, but they had too much internal resistance. They are crappy jumpers for an application like that, or any high power application. So I'm going to replace these wires with other wires with connectors to attach to the spades here so that we get a better connection. I have this 16 gauge stranded wire here, which should do pretty well with 1 amp of current, and if we try to position the module there, that should probably be enough length. And with this tool, adding a little bit more wire where my fingers were, I can snip the wire. And do the same thing with approximately the same amount of red wire right there. This tool also automatically strips the insulation off of the wire. You can adjust it, but in any case you get it between the teeth, get it up to the tongue if you want that much length, squeeze, and you have bare wire. And I repeated the process with the other ends of the wire. Now somebody got mad at me once for not showing what this does. If you close the tool and slide that back, it holds the tool in the closed position there. In my kit here I have female spade connectors, but instead I think I will use a piggyback spade connector. I have some more red ones than blue ones, since they can work with 16 gauge as can the blue ones. I might as well use the red ones for this video. So of course it just slides on just like this, the female onto the male. Then we have another male end right there. We can hold things such as this cover, or we can attach another female spade right there. To crimp the connectors onto the wire, I'm going to use this crimping tool. You just squeeze it, it ratchets until you squeeze it far enough, and then it releases. If you squeeze it and for some reason you can't squeeze it anymore and you want to release it, you just press that little lever forward right there. And then we put the connector into the tool. So the open end over here we put where the red dot is, because it's a red connector. We'll actually do a blue one. Blue one would go where the blue connector is. Pretty straightforward. So the open end of the hole over there is on top. We got the bottom of the connector down there. That's a little flatter. And interestingly enough, it says 22 to 18 gauge for red and 18 to 14 for blue on that one. So now if you're using stranded wire like this, you might have to twist it to get it to slide in easier, and that may not have been good enough, but it looks like it will be okay. And you can see the metal right there. I'll slide it back till just a little bit extra is showing. You just squeeze down the crimping tool and till you squeeze it all the way, and it automatically opens up, and we have our crimp. So here you can see that one dot there that we saw for red, and there's the back, and you should be able to tug on this pretty good and not have it come apart. And now we'll do the same thing for the blue connector. So you can see the 2 blue dots there. Remember that. We come back, the wire's already in there. I'll slide it back a little, squeeze down all the way. It automatically releases, and we should know we have a good connection if we see 2 dots, which we do, and we can tug on it pretty well, and it sticks, which it did not. So we'll attach it to the other side. And so I didn't film it, but I squeezed with more pressure, and this one appears to be attached pretty well. So now on the module you can see out negative. So it's out because this is a battery charger. So it's going out to the battery. We also have out positive right there. All we have to do is unscrew this right here, and we can take that wire out. We don't need that there anymore. I twisted this up. We just slide it into there and we screw it down. Pretty straightforward. And also I made sure that I bent the wire and stuff so the spade is pointing up like this. Remember, it's headed back to that one spade terminal. And of course we did the same thing with the red wire right there. So there you can see it is aimed so that it can slide on pretty easy. The red one's going on easier than the blue one for some reason. Right there, slid right on. Whereas this one's causing a little more trouble right there. But it slid on part way, so that is probably good enough. And we can slide this back there. We have plenty of wire. Right now the screws are hooked on the end, so it's not going to slide around too much. Alright, so now I have this powered up. To set this, I made sure to use these alligator clips here to limit current, because I want to make sure I have the settings right. So right now I have this unit set to charge up to 14.2 volts, and I set it to current. Last time I made the video was set to wattage, so that's the voltage coming in there, minus so it's 9 volts minus some loss in wires and stuff. So now I removed the black alligator clip and just clipped our connector there directly to the battery terminal. It's saying 14.15 volts now for some reason. Those alligator clips, I'll undo the red one. They add some resistance, which allows me to program it. So now the output's off. You can see we got 14.2. So it looks like that's what we are programming it. So I don't know a better way to program it right now. I should read the directions for this unit a little bit better. But there we go. You can see we got a lot of current charging it right now. We are maxing out the current that the power supply can provide. And we're going to lower this right here. And so there's a lot of different ways to program this, but for some reason it buzzes too. I don't know if you can hear that at 1 amp. So not terribly excited about that, but we can charge about half an amp, and the buzzing is lower there. And for some reason it stops when we get the higher current there. So don't know what that's about. But in any case, that's it for this video. Again, a lot more to this than what I showed in the video. This was mostly just for the connectors, but hopefully you still enjoyed it. That buzzing's annoying, so I'm going to go up as high as I can go right there. And it should stop at 14.2. So actually I was about to stop finishing recording this because I'm getting low on time, but the voltage jumped way up. That is actually the battery voltage. I measured it with the multimeter. So since we are close to that 14.2, less current is flowing. And there you can see that we need less current from the power supply. I turn the power supply off, the unit turns off, and I turn it back on, and the settings, they stay the same. So it's out, or it's off right now. I mean, not out. If I turn it on, there you can see we got the same setting. So current went up higher, but you're going to see it drop really quick because we're getting close to 14.2 volts. So since the current is going down, that's because it's trying to keep it from going above 14.2, and maybe it'll stop at 14.15 there instead. So that's what it does to prevent too much voltage going through. It lowers current to prevent from overcharging the battery. So in any case, there's no more buzzing. This isn't going to constant current anymore. It's holding pretty good to what is true. So that was the problem. If this could output more current, we wouldn't have got that buzzing. But in any case, hopefully future topics for future videos. That's it for this one. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.